In this work, we introduce DrapeNet, a framework for generating and draping garments on human bodies with different shapes and poses. Our framework is composed of two parts. The first one is supervised and models garments in static rest pose. The second one learns to drape such garments on various bodies and is self-supervised. For the garment generative network, an encoder is trained to squeeze input garments into compact latent codes. They are then used as input to a garment decoder, which can recover the garment surface by predicting its unsigned distance field, or UDF. The training of this network requires only a few hundred garments in static pose. The second component is the draping network, that contains two subnetworks for top and bottom garments respectively. They are conditioned on the latent codes of the generative network in order to generalize to garments with different geometries. Our draping networks predict vertex displacements and blending weights that are used to skin garments according to a given body shape and pose with simple. Remarkably, the draping networks are trained in a self-supervised fashion by applying physics-based constraints from snug on the draped garment meshes. We generalize it to multiple garments. After training, a fast inference through the garment encoder and the draping network enables draping any garment on a given posed body. As shown here, DrapeNet can realistically drape a great variety of garments. It can process up to 200 frames per second and a standard GPU, enabling real-time draping of animated sequences. Furthermore, the latent space learned by the generative network allows for sampling new garments, which can be reconstructed with a decoder and then draped with the draping network. Thanks to the adopted UDF formulation, the sampled garments present smooth, single-layer surfaces, which is crucial to obtain realistic results. The garment latent codes can also be manipulated to edit specific characteristics. Here, we show we can increase the sleeve length, shorten the top garment, open it in the front, and lengthen the pants. Finally, being fully differentiable, our pipeline enables us to recover 3D models of clothed people from partial observations. By optimizing the garment's latent codes and body parameters while keeping the networks frozen, we show how DrapeNet can be used to recover accurate 3D models from images and 3D scans.